Hey everybody, Mr. Odom here, and I am going to go over Chapter 10. This is your Chapter 10 review, and I recommend that you work out the exercises that you'll see below in your composition books. Give you some extra practice, okay, before you take the test. And the answer key, I'll stop the video down there at the answer key so you can see the answers to the exercises. So let's get started. In section 10.1, we covered outcomes and events. All right, and here's an example where you're randomly choosing one of these toy race cars. And when the question says, in how many ways can choosing a green car occur, then it's asking for a number. All right, so for this first problem, how many ways can you choose a green car? Well, there's 1, 2, 3, 4. You can just count them. So that's why there are 5 green cars. Okay, and that's there's 5 different ways you can choose a green car. Don't forget this word "not." It's an important word. So, in how many ways can choosing a car? In how many ways can choosing a car that is not green occur? Well, then you have to look over here, and I see there's 2 cars that are not green. There's a blue one and a red one. Okay, so there's 2 cars that are not green. So choosing a car that is not green can occur in 2 ways. Now here's another important word when it says, what are the favorable outcomes? Then you have to list them. Then you should write all those favorable outcomes out. All right, so what are the favorable outcomes of choosing a car that is not green? So down here you see the table. You can see here listed are the favorable outcomes of choosing not green. Okay, so there's examples here. You spin a spinner, find the number of ways the event can occur, and then find the favorable outcomes. So I did problems 1 and problem 3. So spinning a 1, you can see there's a 1 green and a 1 purple. There's 2 different ways that you can spin a 1. For number 3, spinning an odd number, we'll have to look at the odd numbers. There's 1 and 3, but there's multiples of each. So there's 5 total ways that the event can occur of spinning an odd number. And then I list the 5 favorable outcomes. Okay, so that's pretty much how you do those problems. All right, you guys can do the rest. Section 10.2 is on probability. And remember, I gave you the little, the way I remember probability is the FO, the number of favorable outcomes, divided by the PO. The FO over the PO, okay? So in this example, you flip a coin. What's the probability of flipping tails? Well, there are 2 total sides, so there's 2 possible outcomes when you flip a coin. One of those outcomes is tails, so that's why you get the probability is 1/2, or you can write it as a percent. Make sure you read the directions carefully. If the directions say write your probability as a percent, then write your probability as a percent. If they say write it as a fraction in simplest form, write it as a fraction in simplest form, okay? Let's look at experimental and theoretical probabilities. So remember, experimental probabilities you can calculate when you're conducting an experiment. So in the first example here, you have this bar graph that shows the results of spinning the spinner 70 times, okay? And you want to know what's the experimental probability of spinning a 2. So you basically have to go to your bar graph and look and see that, hey, this spinner landed on the number 2 12 times. So those are my favorable outcomes again. So that is my favorable outcomes. And then the total, I call it the TO, the FO over the TO when I'm talking about experimental probability. The TO is the total number of outcomes. So which would be 70, because that's how many times you spun the spinner. Okay, so there's 70 total outcomes, 12 of them landed on 2, and you can calculate the probability and then make sure you simplify it. All right, or you can try to write it as a percent. All right, the theoretical probability of choosing a purple grape from a bag is, so it tells you what the probability, so I'm gonna write this down, the probability of choosing purple, it is 2/9 or 2 to 9. So there's 8 purple grapes in the bag. So how many grapes are in the bag? Well, I know there's this ratio right here. This probability is also a ratio of 2 to 9. So there's 2 purple grapes to 9 total grapes. So that's why you see the proportion that we put together here. And you can figure out how to go from 2 to 8. Just multiply by 4. So you multiply 9 by 4, you get 36. All right, let's look at these exercises. And I did number 8 for you and number 12, and you can see those examples. And where it says use the bar graph on page 456, that's this bar graph right here. So for the rest of the problems that you're going to work out, if you stop the video and work these out, that's the bar graph that you need to use. Okay, I'll take that out of there. So you can see what I did to find the probability of spinning a 3. All right, it's a theoretical probability. I need to look at, well, I don't know, how many times did it end up 3? Well, there were 16. And there's 70 total times that the spinner was spun, and there you go. And then theoretical probability is I look actually at the spinner. I look at the tool I'm using, the coin or the spinner or whatever, the dice, and I look at how many total outcomes are there when I spin this spinner, and I count them. And it turns out there are 8. There are 8 different spots that the spinner can land on. 1, 2, 3, 4, 5, 6, 7, 8. And how many of those spots are blue? Well, 2 of them are. So now I can calculate a theoretical probability, which would be 25%. All right? Very good. Let's talk about compound events. And this is where we learned about the fundamental counting principle. All right? That says, hey, let's look at this example. It's how many different home theater systems can you make from 6 DVDs, 8 TVs, and 3 brands of speakers? So the fundamental counting principle says, hey, if you want to figure out what the PO is, the number of possible outcomes, then all you have to do is you just have to multiply the number of outcomes for each specific thing that you're looking at. So for here, DVD players, there are 6 possible DVD players to choose from. There are 8 TVs to choose from and 3 brands of speakers to choose from. So that gives us 6 times 8 times 3, which is 144. So that's how you can calculate the PO, the number of possible outcomes, using the fundamental counting principle. All right. We also learned how to make a table, which comes in handy for, sometimes when you have things like coins or 6-sided dice, things that are small, where you don't have a lot of choices. So coins is really good because you only have 2 choices, heads or tails. So you can make a table. So here you flip 2 pennies. What's the probability of flipping 2 heads? So notice how I did this in the table. So this is my first flip. I could get a head or a tail. And then here's the second flip. In the second flip, I could get heads or tails after I got heads. After I got tails, on the second flip, I could get heads or tails again. And then all you do is you build the PO. These are all the possible outcomes. And so how many are there? There's 4. Okay. How many of those have 2 heads? Well, there's only 1. You see it circled in red. So that is your favorable outcome. And you get 1/4 or 25%. All right, I leave these 2 for you. If you need help on them, just ask me in class. The answers are below. Finally, we talked about independent and dependent events. So for the example, you randomly choose one of the tiles and flip the coin. So the thing to think about is when I choose one of the tiles, does it impact the result of when I flip the coin? It turns out that it doesn't. So these events are independent. So that tells me which formula I need to use. Okay. It says the probability that these two events, A and B, of choosing a vowel and flipping tails, are independent. So I can find their probabilities independently, and then I just multiply them together, which you see down here. You get 1/7. All right. And here's the exercises, and I looked at a couple of these for you. The first one, you randomly choose one of the tiles and flip the coin. So remember, these are independent events. So you want to find the probability of choosing a blue tile and flipping tails. You see the work I did down here. I find those probabilities separate from each other. So the probability of choosing a blue, well, there's 4 blue and 7 possible outcomes. So that's 4/7. And then tails, it's 1/2. And I get my answer, 2 to 7. And now you randomly choose, for this one, you randomly choose one of the tiles without replacing it. So you don't put it back in there as one of the tiles you could choose a second time. So you have impacted the likelihood of whatever the next event is. So these are dependent. Whenever you see this without replacing, think dependent events. All right, so we have to find the probability of this compound event. I worked out 21. The probability that you choose green and then you choose a blue tile. So it's after you've already taken the green one out. So notice the probability of choosing a green, well, there's 2 green out of the 7 tiles, is 2/7. And then the probability of choosing blue after green. So if I take out one of the green tiles, let's say this one, then look down here. There are no longer 7 tiles to choose from. So the likelihood of choosing a blue has changed. That's why these are dependent. And so you do the math, you get 4/21, or about 19%. All right, so I'm going to scroll down here so you can see the answers to all 22 problems. And you can use those to check your work if you work these out. So that's all I have for this video. Hopefully that was helpful for you. And this is Mr. Odom, and I am out.